Oops, there we go. Welcome back, everybody, and today's third session, if you've been with us for a while or if you're new. I'd like to introduce Janet Bell, and she's been with the ERLC as a consultant for a while, and she was a English teacher originally and worked from a classroom teacher towards a consultant. She's co-led ed tech integration across the province as the member of tolearn.ca, and been on the ARPDC provincial teams. And she was also district leadership as the department head at Lillian Osborne High School with the technology integration and planning supports. And as a consultant with Edmonton Public, she's a Google certified trainer and a SMART certified trainer. So she's got a lot of tricks up her sleeve, as when I've been in meetings with her, she always brings a little something about technology that makes our lives more efficient. And I think today's session is something I'm excited to be a part of, because this is all new for in our curriculum, and to see ways of bringing this to life in computational thinking and computer science. So I'll hand it over to Janet. Welcome, everyone.
So yeah, thanks for that introduction, Nicole. That was like my life history for you. I'm really happy to be working with Nicole on the science team. And if you were in Nicole's session yesterday, you'll know she has such a wealth of information and such a depth of understanding. And so to have her here as moderator today, I think is like just so valuable for all of us. And so feel free to tap her brain as well as mine as we go through today. I learn so much from Nicole every time I chat with her. So thank you so much for moderating. If you have any questions and things, add them in the chat. And any comments, and then we'll find time, and then Nicole's going to kind of help me like move through that dance with the chat as well. There's tons in this presentation, and I'm way over prepared and took out a whole bunch of slides yesterday thinking this is like overkill. So I hope it all goes well. Please be honest in the chat. I want this to be the best value that it can be for you today, and lots of resources to share. So yeah, looking forward to today. And me being this like have this odd techie gene, I decided to use a high stakes presentation in order to do something completely new. So what I decided to do was to use Lumio, which is sort of the evolution of Smart Notebook, which probably everybody knows of from back in the day. And so if you can follow along, you could follow along in like through the Zoom call itself, of course, where I'm sharing my screen, but every now and then I will be demonstrating something or asking for input using Lumio. And so you could either just scan the QR code and look at it on your other device. Somebody made the comment, it's looking a bit small on a phone. So maybe if you had an iPad or a large phone. Otherwise, the link is in the chat. So you can just click on that link. You just join as a guest. And then that'll take you sort of say you're a student and join as a guest, and then that'll get you into the Lumio file. Or if you don't want to click on that link, you can just go to hellosmart.com and enter the class ID 132469. But of course, clicking on the link is easier. So I'll just pop that in a couple of times in case people are still joining. So shall we get started?
I think so. That sounds great.
Okay. And so you can all see my screen, and Nicole, please let me know if there's sort of any issues with anything. So what I'm doing is I'm kind of going to be going back and forth between my Google Slides and Lumio. And so this is the description of what we signed up for today. And so when I broke it down into its parts, I guess using the computational thinking word, when I decomposed it, basically we're going to first of all like look at defining what exactly is computer science and computational thinking. We're going to kind of integrate and expand it. So take that big picture definition and put it into the curriculum, and then kind of apply it and ideate and think, how can we teach it and support each other? And then I have resources and next steps. And then before we get into that, I do want to look a little bit at the big picture. And yes, fantastic, Nicole. So what's interesting is Nicole and I have been, working through our own sort of organizing ideas in the curriculum. And what's been kind of coming out of that, just kind of coming to light through that process, is there is so much overlap between computer science and scientific methods. And so as we go through, if Nicole can, like, as you see those little pieces coming in and can make those connections in the chat, that would be really fantastic for us. Thank you. One of the things that's different, or I think the biggest thing that's different between computer science and the other organizing ideas, is that pretty much nobody's had any training in computer science, so we don't even know what it is. So if you have an organizing idea of living systems, at least we sort of have some experience and knowledge and education in it ourselves. And so the big thing with computer science, of course, is we're asked to do something and we don't even really know what it is. And there's lots of ideas and lots of stress. And so a big part of my goal is to kind of show the importance of it, but also to show that this is not a big deal. This is definitely not a stressful thing for people. And so that's kind of the approach in the big picture, is to try to get that big picture sorted. This question in the chat about how do we change the slides on the Lumio presentation, they should be changing automatically for you. So if you find that you're stuck on a previous slide, just refresh your screen and it'll pop you up to the current slide. So here's a little bit of big picture. There was this link here, the K-12 CS framework is it's Learning for the Digital World, a pan-Canadian K-12 computer science education framework. And there was representation from the University of Alberta on that by Dr. Kathy Adams on that committee. And this is in their research across the province, 2/3, you can see that across there. The part that jumped out to me was the end, that 7 of 13 provinces and territories include computer science skills and competencies in their elementary or middle school curricula. And Alberta wasn't one of them. And so it's funny, I've always thought of Alberta as being such a leader in education, and we are in so many ways. But as the world continues to change and evolve, it's time for us to be teaching computer science. And so I thought I would ask you why, and I'm just going to move this thing around on my screen, like why, from your perspective at this point in time, before I kind of dig deeper, but why? Oh, I see what you mean. Right. I'm going to go back to that. Yes, I know exactly the answer to your question here. That was my mistake.
There seems to be quite a few people who are stuck.
Yes, it will be everybody. Now you will see that it has changed. So I'll tell you what I did. So why should our students be learning computer science in school? And so what you'll see is, yes, I'm just going to back up before you answer the question to help with the technology piece. As I build this bridge, as I walk on it, you can see at the top of my screen, I have my Lumio tab and I have my Google Presentation tab. And so when I'm going through my Google Presentation, that's where you need to be watching on the Zoom call. And so I will tell you when to flip over to the Lumio to see the Lumio. And usually it's all in Lumio. It's just because there's so many slides, I decided to keep them separate. Yeah. So on the little box that you will see for writing the answer, the question is that question of why should, and so this is showing on your Zoom screen, why should our students be learning computer science throughout school? And it's at the top here too. Why should our students be learning computer science throughout school? And if you can just jot down a reason why and drop it in, and we can watch our Lumio board fill up. And I'm not going to read them aloud because I'm hoping to have 139 responses. And I set up I set it up so that I think you can answer 10 times or something, but that you'd have to be really enthusiastic to have that many responses. But I am going to click in and out of a few of them. And so once you've added yours, you can come back to the Zoom call and you'll see everybody's responses being displayed within Zoom. So I'm just going from the corner, because the future is now. We live in a world of technology. It's better to learn at a younger age, so they have the skills necessary for the future. This is a very future forward response. It's become a life skill needed in most jobs to prepare students for jobs in the future that don't currently exist now. So after this presentation is over, I will be taking these responses and adding them into the Google Slides, so you will have access to these. So once you've added your response, just come back to the Zoom page and you can just see as I click in and out of a number of them. Ooh, I like this. The general skills are helpful to deepening your thinking. When I think of knowledge, understanding, skills, and procedures, it's interesting how so many of these comments, there's a lot of career-oriented comments, but a lot of them is looking at knowledge, understanding, skills, and procedures. I'm going to keep going. I just want to keep looking at those, and that'll take us a while. I'll tell you, one of the things that for me, and as Nicole said, my background is as an English teacher. And so it's like my whole career, there's always this literacy lens. And as you know, we in computer science, there's like a literacy and learning to code or whatever, but really we live in a world where, there's ChatGPT, there's people not being like polite to each other on the internet, there's fake news. Like literacy
The
is
last story
so
you read,
much bigger.
the last idea you responded to,
Can you hear that?
the last movie you watched, the last piece of music you listened to. Did you make that decision? Or do you somehow, in ways you might not understand, that decision is being made for you? What's going into that decision? Pictures, numbers, patterns, words you provide, choices you make. It's like someone or something is reading your mind, predicting what you do, sometimes helping you, sometimes playing with you, sometimes playing you. How can we make sense of all of this information that surrounds us? Is it all one big mess? Or is it just data? What if data was something that you could make sense of? What if you had a better understanding of how algorithms use data to make decisions from your decisions? And what if you knew that you didn't have to be a coding expert or data scientist to gain the basic skills you need to use data for good? Learning about data literacy is an essential first step to understanding what's going into a decision and to make informed choices. Data is at your fingertips. You might be surprised by how much it impacts your life and the lives around you.
Okay, so come back to the Zoom call if you're still looking at your Lumio. I'll be showing the slides as I present right through the Zoom. So hopefully you were all able to see that video. And,
the last story you read. The last.
And now I'm going to kind of get past that big picture thinking, and let's take a look at some of the definitions. So are you all back to the Zoom? Give me a thumbs up if you can see the screen that says part 1, define what exactly is computer science and computational thinking. Good. Okay, so here we go through the Zoom call. The question I am kind of looking at is, what is computer science, and also how is it situated in the curriculum? And there's kind of a couple, it's kind of like a couple kind of definitions, because the way it's described in the curriculum is a little bit different from the way that people look at it generally. But I think that they're really compatible. So this is the organizing idea within the curriculum. And so if we think of the concepts within this idea, we have a few different concepts. So computer science, problem solving, and scientific inquiry are developed through the knowledgeable application of 3 things: creativity, we kind of have a general idea; design, some of us will have better idea than others; and computational thinking, which is that blurry piece for lots of people. And so what I would like to do is look at what is computer science, but really focus on that computational thinking piece, because I think once we have an understanding of computational thinking, that will open up, I think, clarity in terms of the other pieces, and also in terms of how it connects to what Nicole was talking about with scientific method. So I have a strong belief, and it must be out of those stories, you know, that we used to all hear years ago about how there are so many words for snow up north. Is that if we don't have a name for something, then we don't really know what it is. This is the English teacher in me, right? And so to give a sense of what computer science is and what computer science isn't, I think we need to know like the different pieces, and so we can name it. And so computational thinking is the mathematical thinking that informs coding, and coding, which is like programming, is a subset of computer science. So if we think of everything to do with computing like this, computer science is that red circle, and computational thinking overlaps it, but it's, whoops, let me head back there. I don't want to go to that link. Yeah, so you'll see everything links. Computational thinking overlaps computer science, but lots of computer science isn't computational thinking. The history of computers is part of computer science. That's not part of computational thinking. Programming overlaps computational thinking, but there's lots of computational thinking that isn't programming. So if I'm using computational thinking to figure out how to organize my closet upstairs, that's not programming. So coding and computer science are not the same thing. It's a subset of it. And coding and computational thinking are not the same thing, but they do overlap. So that's just a little bit of a sense of it. What we're looking at when we talk about computational thinking in terms of computer science is really this middle piece of the set. So there's lots of computational thinking we do that isn't computer science. This is what we're looking at in school. But as teachers, we all know that the more you understand that big picture concept, of course, the more readily you're going to be able to apply it to things that you're doing within a subject area. So that's why I wanted to really spend some time on that Venn diagram, and to have you start to wonder a little bit about how you're using computational thinking in your own, just in your own life, as well as in school. And so the computational thinking process, as I say, it applies far beyond computer science. There's basically, it's like a circle. And so the first part is problem solving. So I have a problem. The first thing I need to do is decompose it. Maybe it's a problem. How am I going to, I can't think of an example of it. How am I going to clean my teeth in the morning? Well, I have to break it down. Maybe I have to check if I have toothpaste. Maybe I have to find my toothbrush. Maybe, you know, so you take that problem. Maybe it's a number of different problems that are all tied together. Maybe inside each of those problems, I need to take those problems apart, and then I need to look for patterns in it. It's like, oh, right, my son always puts the toothpaste in this other drawer. That's why I can't find it. This happens all the time. I bet today it's the same thing. Then you have to abstract. So I'm thinking, oh, my son's going to be late for school. Oh, that's not part of this problem. I will take that away. So you clue down on the most important parts of your problem. And then algorithmic design is coming up with that step-by-step instructions of how I'm going to solve that problem. So that is what, that is kind of in a nutshell what the computational thinking process is. And it's a process that we use in coding, but it's a process that we're using all the time in our lives. And Ruth has just mentioned that it seems like the slides don't match. So the slide you should be seeing is the one that says computational thinking is a problem-solving approach. The Lumio slide, yeah, the Lumio slide is just this one. Don't click on that link. That's more there just for me to make sure I go to the right page. It should say computational thinking. So if you can't see that page, make sure you are that you have flipped to the Zoom call because my slides are the ones that are coming through the Zoom call. So computational thinking, this is another definition by Jeanette Wing, who is like, to me, she is like the mother of everything computational thinking. She's at Columbia University. She used to be the head of Microsoft Research, and she used to be an assistant director at the National Science Foundation. She says computational thinking is the thought processes involved in formulating a problem and expressing its solution in such a way that a computer, whether it's a human or machine, can effectively carry it out. And when she talks about thought processes, there's a video I have that I won't play for you, but I'll show you where it is. She talks very specifically about how she, as a computer science, wonders how students in school can learn all of this. And her hypothesis, I guess, was what about if when students learn in math to do long division and are practicing it over and over, what if the teacher were to say, we've learned how to do this, and now we are going to apply that algorithm, that step-by-step instructions. We're going to apply this algorithm until we're more familiar with it. And so when her sort of message that comes out of that is that you need to name it to know it. If you are using instructions, giving instructions, having students create instructions, then if you start using the word algorithm, which doesn't come up until I think it's grade 5, but if you just start kind of using it, then they will know what it is. And even if you don't use it in Div 1, when you start using the word algorithm, it'll be like, oh, it's instructions. We've used the word instructions. I guess all it is a fancy word for instructions. In Nicole's presentation yesterday, she mentioned the Carl Sagan quote where about science being more than a body of knowledge and about it being a way of thinking. And I thought that applies to this so well, is that computational thinking, the same thing. It's not a body of knowledge, it is a way of thinking. And when I, after Nicole's presentation, I Googled the quote to see if I could find more. And I recommend you do that because it actually leads into a commentary by Sagan, kind of looking at rather a bleak picture of where the world would be if we don't have that ability to be able to think in a scientific way. And to me, that goes back to that notion of literacy again. Anyway, computational thinking, planning a road trip, right? I want to get from here to here. How am I going to break down maybe like each leg of the trip? What are the pattern recognition? Where are we going to we need to eat every day? Where will that fit in? Take out the irrelevant. So organizing a closet, and I'll let you read, kind of skim down those. So all of these are examples of computational thinking and not necessarily coding itself. So knowledgeable application of computational thinking develops one ability to problem solve. And of course, in the curriculum, it says computational thinking, design thinking, and creativity to promote scientific inquiry and problem solving. So it's, to me, it's the key, but I think this vocabulary is the biggest takeaway. And so computational thinking is about becoming a mathematical thinker, not a calculator. And one of the things that really struck me when kind of immersing myself in it was, as we teach our students to become mathematical thinkers, they can, we're teaching them to be the people who decide what the instructions will be, rather than us always telling them what to do. And so I should still have the link to the Lumio. So for those of you who joined late, we are working within 2 tabs this morning. So there's the Lumio tab when I want to demonstrate something that's a little bit more interactive, or get feedback in from you. And then there's the Zoom link itself, where my screen will always be displayed in the Zoom. So when I click back to the Google presentation, that's what's showing in the Zoom. So the Zoom, think of the Zoom as your grounding anchor for the presentation, but then at times I'll be like, let's go to the Lumio. So the Zoom tab is where you need to be. So we're going to flip back to the Lumio. So given that computational thinking is these definitions, you're breaking your big problems into small manageable problems. You're then going to look for patterns and connections between things, focusing only on the important details, getting rid of, oh, awesome, Sharon, getting rid of the irrelevant information and designing simple steps. We're going to go back to Lumio, and what I'm going to do is just show you, I think it's like 3 examples of where the question is this computational thinking, and what of this language do you see being demonstrated in this example? And so for this one, what we'll do is we'll just use the chat. So what I had originally done, yes, it's definitely interdisciplinary. Yes, like in capitals, yes. As an English teacher, when I heard that computer science and computational thinking was in the science curriculum, I was like, what? It should have been in ELAL. But it is definitely cross-disciplinary. If I have my little robots and I am programming them to retell the narrative arc of a story, I am using computational thinking and I'm using computer science. Absolutely. So anyway, back to our Lumio. So you can look
sorry,
at—
Janet, I'm just going to introduce, because someone's asking for the class ID and I don't have that offhand.
Oh, I think it's 132469, but you can just click on that link. It'll just take you straight there. Oh yeah, look, it's even inside that. So you can go hellosmart.com 132469, or you can just click on that link, which I'll just drop in again. So in these examples, when I originally put this file together, I did make them interactive for you to snoop around. But then when I came back, I decided just to make them demonstration because of our time constraints. But when you come back afterwards, you will have access to them to be interactive. So the question, which I have in that Zoom call, is where kind of the big picture is what might it look like in my Division I classroom. But it's like, okay, is this an example? Let's apply it. Is this decomposition, pattern recognition, abstraction, or algorithmic design? And so I have a little old-fashioned notebook file that I found on the, what is that, the Lumio website when you search for resources. And I thought, okay, I did a little search on Learn Alberta, and I found, okay, this fits grade K to 12 as a resource. What makes a plant? It fits science grade 2 learning outcomes. A life cycle shows the different stages in life that a plant or an animal goes through. And so that's where it fits in science. And so I'm thinking, and this isn't applying the computer science outcomes so much as I just want to see if you know what computational thinking is. So if I go to this first slide, so here's an activity where the students have to put the name of each part and its job inside the boxes. So if I am thinking, okay, so I'm going to put the, move things into place in my notebook activity, am I using— so what were those things? Like, am I using decomposition? Am I using pattern recognition? Am I using abstraction? Am I using algorithmic design? And so just add in the chat if you see computational thinking, as we think of our own teacher understanding of computational thinking, what kind of part of computational thinking will a student be using if they are building, working in an activity like this one? Certainly decomposition, right? Because we're having to look at the plant and we're breaking it into its different sections. It's interesting as an English teacher when, teaching high school, we would have a poem and we would deconstruct it. And so we would talk about deconstruction, not decomposition, but I mean, really, I think it's the same thing. So yeah, so we're taking that into its different parts. So here's another example. Whoops, I just went too ahead. So if we were to ask people to take the red X and place it on top of the items that a plant does not need, so a plant does not need a printer, for example, what are we doing there? Absolutely. So we're getting rid of the things that don't apply. So when you think of activities that you're completing with students, whether in science, whether in any of the other subject areas, when you're applying those processes of computational thinking, I would say use the words, get them used to those words so that they become familiar with them, and it brings those concepts to life, so that once we get further along and they start actually using them and doing more traditional computer science, moving into coding in grade 5 and above, these are not going to be unfamiliar, stressful terms for them. So here, when we're looking at move the pictures to the correct box to show the order of the life cycle of a plant. So moving things into an order to show that progress. And I was a little unsure of this one myself when I was putting together. So I was kind of thinking the notion of sequencing in this, but I think, yeah, perhaps it's pattern recognition as well. But certainly, yeah, the sequencing, we're looking at that algorithm. I'm not really sure why there's a frog. Maybe you know, or maybe it's a mistake in the phone. Thank you. Adult frog, right? I don't know. Maybe it's like a distractor. It's working that way. Anyway, so you'll see on your Lumio file, and this is where I've kind of integrated my slides together, but probably best to look on the Zoom link, either one, I guess. And so, yeah, exactly, Sharon. So the kind of assurance that I wanted to really, like, the big message to get to you is that, number one, name it to know it, but also the computational thinking. And this image, and also that you saw earlier, is from a website called Digital Promise, and they go into quite a bit of depth. I'd really recommend it as a resource. But anything that you do when you're fulfilling those outcomes in computer science is that you may be using tech, but you may not be using tech. You don't have to do coding until grade 5. You do work with instructions. So you can do coding, you can do not coding. Like, it's totally up to you as you work through those the pieces of computational thinking. And this TPAC image I have over on the right-hand side of the page here is one I often talk about in other presentations. And it's just this sort of philosophy of technology integration, where when we're working with students, the most important piece for us to know is the context of our students. So even in our kind of chit chat before the presentation here, someone was talking about their internet being really iffy. Well, if your internet is really iffy, probably your choice of the types of activities you're going to do with your students are going to be a little bit different. Exactly, multiple entry levels. And then the other piece from a technology perspective is you focus on the context of the students, and at that meta level, as we learn about computational thinking, it's the context of our peers as well as teachers. But we focus on our content knowledge, then our pedagogical knowledge, and the techie piece comes last. And so today, the content knowledge is computer science, but to sort of know that there are many ways to teach that content, and it doesn't have to be using the technology to do that. So we just wanted to make that clear to you. So, whoopsie, next slide. So takeaway number one, name it to know it. And so now I'm going to ask you, how are you using computational thinking in your life at home and or at school already? So on our Lumio, now you will need to go back to your Lumio tab. And I have this slide up there, and I'm just going to make sure, yes, it looks like you're in it, right? You can see that. Now, unlike the other slide where that was called a shout it out, where you could put in your definition or your answer in the box and it put it up on the screen, this one is just a shared screen. So I expect it might fill up rather quickly and I won't spend too long on it, but just think, how are you using computational thinking in your life at home or at school already? And then just go over to the side and click on the little box, and then you can just write. So I use it when I fill up my car with gas. And so if you want to, for those of you, if you want to use if you want to just use the line, or if you want to click on here, you can do it any way you want. How are you using computational thinking in your life at home and or at school already? Board games. We have people doing coding with their students. Oops. It's fascinating to look at the content and the style of what we're putting together here, right? Assessment. Right. Oh my goodness. Rubrics, and it's all. And Kristen has asked, it's like the question, it was the first question that I had when I looked at this new curriculum was, could I still do coding in grade 4-3 combined class? Well, I was just thinking in division 1, because for me, I just have a thing for those little robots. And actually in September, October, and November, I think it's the last Thursday, or maybe it's the second last Thursday of each month. For those of you who are close enough to Edmonton, we're going to do some drop-in sessions at Elmwood School where you can come and play with my robots. Okay, so Sharon's wondering how, so it's this link here gets you to the Lumio file, and you would just sign in as a guest, and then it should take you to this page. Kristen says, coding is great at all levels and Scratch is easy to learn. Oh, yes. B-bots, yes. I think I'm going to have to move on because I want to get to that stuff. Thank you so much for all your comments. You can see that it's that idea of name it to know it, right? Like if we don't think that we know about, if we don't think that we know about computational thinking, then but it's like, once we know what it is, if we use the vocabulary, then it just becomes really part of the vernacular. Okay, I'm going to make sure that I'm on. So now come back. I'm just going to close my other tabs here because it's getting a little bit. So come back to the Zoom call because I'm going to flip back to my Google Slides for the next little bit. So on this page, what you should be seeing in front of you is it says part 2, integrate and expand. And I put just some little screenshots of those images that you looked at, just as kind of a backup. So you have those just to remind you of that conversation. So back to the front matter of the science curriculum, and this is what it says. The study of computer science allows students to apply creativity, design, and computational thinking, and to develop scientific inquiry, which is, I think, what relates back to Nicole's focus, and problem-solving skills. Students will employ design processes, so that's the blue part here, right? Creating instructions, algorithms, we know that word now, and computational artifacts. And they'll also engage in, this is very computer, coding activities. And then also that bigger picture computer science that isn't actually computational thinking, right? Consider the impacts of computers, coding, and technology. This link here, I'm just going to copy and paste. There's a little package of resources that Nicole will be sharing with you at the end of the session. And this link is to, I took the whole science curriculum and pulled out just the computer science pages. I think it's about 6 or 7 pages. That's it for all of K to 3, and put them all in one document. So you can take that as a takeaway. And so we're looking at design thinking. So in terms of the definition of design thinking, like computational thinking, it's an approach to problem solving that emphasizes empathy, creativity, and experimentation. And I know that there's been some little bit of chat about design thinking in our chat, and feel free to continue that conversation as I give you a super brief overview. So when we talk about design thinking, some of you may know the work of John Spencer. And if you don't, you can just like jot his name down, John Spencer. And oh gosh, who's the other guy? Last name AJ. What's the last name? Anyway, John Spencer is they sort of work together. So they've done quite a bit of work on the design thinking process in schools and relating design thinking, AJ Giuliani, that's it, design thinking to project-based learning. And so the process of design thinking is, I have a problem. I have, someone's given me a pile of paper clips, and I have to come up at my table with all of the different innovative things I can create when all I have is a pile of paper clips. And so I have to think, what are some problems that could be out there? And you talk around to your table, you come up with a definition of, okay, I need to find a way that I can hang some pictures. And so then I will ideate, well, I could do this with a paperclip, I could do that, I could do the other. Let's make something and prototype it. Let's test it and see if it works, and let's implement it. So that is your design thinking process, from understanding what the problem is to exploring all of the different solutions that could possibly be, testing them out, and then making something, implementing, kind of taking it to market or whatever. So that's the design thinking process in a nutshell. So if we think about all of that computational thinking and we think of the design thinking process, then you can see how it could work together. Because if I am going to, for those of you who are using Scratch, right? If I am going to put together a Scratch program that is going to, show the life cycle of a plant, then I am going to have to design what it's going to look like, and then I'm going to create it. So the design thinking and the computational thinking very much overlap. This is the organizing idea again. And as I was trying to kind of deep dive myself into it, I thought, well, we've got creativity, we've got design thinking, and we've got computational thinking. And each of them has these processes. And then, of course, we've got scientific method that Nicole's been chatting about, and how do we pull it together? And what I realized is it's not as complex as it appears, because in grade, and I always mix these grades up, in grade 2, I believe it is, we are introduced to creativity. It's not these big words that we have on the left. What it says in the curriculum is creativity is the ability to generate something original, such as ideas, technology, tools, and products. So that's really basic. And then computational thinking, at the end here, computational thinking first appears in grade 3. So in grades 1 and grade 2, the word that's used over and over again is instructions. And then in grade 3, suddenly it's called computational thinking. And yes, I'll get to that question in just a sec. So computational thinking in grade 3, this is from the curriculum. Look how similar this is to the other literature about computational thinking. Breaking a task into smaller chunks, decomposition, finding patterns and similarities in tasks, identifying important details, the abstraction, designing instructions, algorithmic design, and then this is the debugging part, working backwards. So very much in terms of the vocabulary, right, in grade 3 is computational thinking. And then design processes come up in grade 4. And it looks specifically at understanding the problem, forming ideas, planning, creating, analyzing, testing, and troubleshooting. So very much like the process in here. So I'm just going to back to the chat because I know there's Kristen's been asking, should we be breaking this up and teaching each step before getting students to use this for a project? And the reason I ask is my principal wants us to showcase an inquiry-based project in February to our staff. That's a cool challenge. And STEM challenges. Yes. Yes. So my thoughts on that, and Nicole, feel free, because I think this is a good question for you as well, but from a computer science in the curriculum perspective, I think that the value is in immersing students mindfully, and the word that's used in the STEM, right, is the knowledgeable application. So mindfully immersing students in activities that have them use like this computational process and being able to name it to know it. And as they become aware of those, then, and this is back to Nicole yesterday, she talked about that whole idea of explore before explain. And I think once students are exploring before you explain what they've been doing, and then they can relate what they've been doing to what they've learned through exploring, I think that so it's not like sequential, it's immersion. So and then that would relate to Leslie's comment about STEM challenges, because, gosh, I'm watching the clock here, because when we, and this is my personal bias, is the little robots, but you don't have to use them if you don't want to. But the beauty to me of some of those cross-curricular STEM challenges is that students get, they will create a product to represent their learning, but it won't work out. So they'll write that computer program or make their robot go somewhere, and it'll fail. And it's that failing forward notion. Like as soon as you create something and you know it's going to work and it fails, it's like something in your mind grabs onto it like a dog with a bone, and they are inspired to learn and learn and learn. Now, Nicole, what do you think of that? Because that is me talking from my experience. And
actually, well, I can come at it from a scientific method lens as well.
Yes,
thing, right? Because it's like, should I teach the process? And yesterday, and I'll be really quick about this, when in your grade level handouts that you got yesterday, I have a video section, and it talks about how when you teach it as that, like you introduce it and teach it, students will develop a misunderstanding or a misconception that it's a step linear process, when even like looking through this, you can see it's a cyclical process. So and what they suggested, exactly what you suggested, Janet, is that the students go through the process and then they go back and they name the parts of it, just like we did with what you were asking us to do today, to go back and identify the parts of where they've done it.
You know, language brings clarity, and yeah, it's that, and that to me, and everything everybody said early on about all the reasons we need to do this in the future, 100%, absolutely. And it's like the language is the key. Thank you, Nicole. So I'm going to move quickly here. So of course, the other piece in there was the creativity. So creativity is the ability to generate something original, such as ideas, technology, tools, and products. So that's what comes out in the grade 2 piece. This link here actually just takes you to that same link I shared in the chat earlier, the science curriculum. There's our design thinking. This is where that vocabulary breaks down from grade to grade. So K-1 is instructions, instructions, instructions. Yeah, keep that STEM challenge conversation going. Yes. Creativity in grade 2, computational thinking in grade 3. And then in grade 4, there's the phrase talks about design processes to meet needs. So it's very much a sort of empathizing to find the need. And then the word instructions is replaced with the word algorithm. And then grade 5 and 6, we start using that actual language of coding and design thinking. So just like in Chris's presentation the other day, you know, where she had that picture of that funnel where everything is recursive and building up, that's the same thing. Everything is strategically moving from grade to grade. And if you've got those pieces in place in the early years, then when they get up to you know, grades 4, grade 5 and 6, it's like, oh yeah, we've been doing this all along, which is, I think, strategically rather elegant. So there's our organizing idea. How can it best be situated? Getting down right into the organizing idea itself. And I'm wondering if I missed a piece, but we'll just keep going and see. It integrates with the other organizing ideas. So hopefully you see this clearly, because we looked at, in general, computational thinking in the life cycle of a plant earlier. So these are the organizing ideas that we have in science. And as you know, living systems isn't in kindergarten. Computer science does go all the way through. And oh, good, this is where I want to be. And Nicole and I gave this presentation a month or so ago. And as we were working on it together, it was a real eye-opener to think of her investigation cycle, which is amazing. And someone yesterday was asking for the big poster of it, is to think, okay, how are those computational thinking pieces, how do they actually overlay onto the scientific method? So what I'd like you to do is, if you just flip back to your Lumio file, what I'm going to do is maybe I will put you into some teams. So I'm going to put you into 9 teams. And so if you're on the Zoom, you can see everybody being pulled into teams here. And I'm going to start the workspace. And so, I need to show you what it looks like. So inside the workspace, what you're going to see is, so if you just click your way in there, you'll see the investigation cycle and you'll see the computational thinking process. And so what I'd like you to do is just go over to this side, the left side, and say, okay, so decomposition, where might I be doing that? So maybe when I am asking my questions, maybe I'm having to pull things down and put them into their parts. Maybe I'll move that up like that. So just in your team, go into your page, and each of these are just like old-fashioned Smart Notebook. We have the infinite cloner on them. You can just drag pattern recognition. Where would that go? And I'm going to zip in and out between the different teams and see if you can see where you're putting these different elements, so you can get a sense of how they may overlay on each other, or maybe the whole cycle can be inside one place or other of the investigation cycle. So we'll just spend a moment doing
Janet,
that.
I'm just going to interject because Christine has the same issue that I'm having, which is that when I go into the thing, it says the activity's already started.
Okay, thank you for that. I will just do a reset. So I've taken everybody out again, but it's because some people, I think, just joined. So we're going to start with the people who are in there now. And what I'll do is I'll be flipping back and forth among the pages on my screen. So if you weren't able to get in there for one reason or another, then go to your Zoom call and you can follow along with me as I look through. Sound good? So I'm going to go. Oh yeah. So how do I get there on Lumio? This is, whoops. I'll just grab that ID again. So if you are not in Lumio, this is the link to get into the presentation itself and just join as a guest. And then I'm going to take the people who are in there. I'll just give you just a little moment because I know it just keeps changing a little. Yeah, it isn't running the activity. I'm just about to run it. So that's the right thing to see. Okay, so you need to be not in the Google presentation side, but the Lumio side. And that's by clicking on that hellosmart.com link. Or you can also go to the Zoom window and then you can just follow along with me. So I'm going to make 9 different groups. Everybody's falling into those groups. And I'm going to say start workspace. And you can see if you're in the Zoom, which you don't have to be, all the names of the people who've been put into our different groups. And I'm now going to click in on the Zoom. So if you haven't been able to get into it, then you'll have to follow along. Yeah, we've had some more people that have joined since I started it. So if it says the activity is already started, then just flip over to your Zoom display and then you can just watch people with me as they do it. And we'll just watch. So I'm just flipping from team to team. So we've got decomposition, pattern recognition, abstraction. With so many icons moving across the screen, I have a compulsion to do more decomposition, just decomposing things into their parts. Nicole, what are your thoughts about what we're seeing here from a investigation cycle perspective?
Yeah, and abstraction for sure is going to come out in the conclusions, the inferencing, because you're making an explanation and generalizing. I love this. And pattern recognition, it can happen before because you're anticipating in a prediction, but also when you're analyzing the data, you're breaking it down and looking for patterns. It's awesome. Love it. It's a great activity.
Yeah, it's so interesting when you think of, you know, in Chris's presentation, when she talked about TED's concept maps, and to me, it's messy, but it's real, right? This is how we learn. It's like, oh, we've done this. It's this name, it's this name, it's the same thing. That's what real life is about. And it's not about the silos of English and science and math and social. It's moving things together.
Seeing connections, yeah.
No, I'm just being distracted by them all.
I love that you can see this live. I'm sorry, I'm just gonna make that comment. I was like, oh, I like that.
You love what? Sorry.
That you can see this live as people are moving it.
Yeah. Yeah, it's fascinating. Anyway, on we go. Thank you very much for that. So as we go back to come back to not the Lumio screen, come back to your Zoom screen. And so then you're going to be seeing my Google presentation again. And we'll continue. So the organizing ideas, the big piece, of course, inside that computer science organizing ideas, that problem and scientific inquiry. And so hopefully through that activity we've just completed, you can see the value of that overlap of that investigation cycle with computer science and how they fit together. This I have mentioned already, so I'm just going to scoot through it, but this just shows you that evolution of all of those concepts again. K-1 is focusing on instructions, which of course is learning how to follow an algorithm and then moving towards like creating an algorithm or creating instructions. And grades 2, we look at creativity. Creativity is the ability to generate something original, such as ideas, technology, tools, products. And we look at instructions and creativity. Grade 3 is computational thinking with that definition. It's a problem-solving process that uses creativity. So you can see how they build on each other. You get to grade 4 and it's design processes, the definition, and that it can transform ideas into artifacts. And you're creating an artifact to create a need. And it talks about the idea of designing, collaborate to design an algorithm to solve a problem. So we see that the design process and the language of computational thinking kind of blurring together in grade 4, and then grades 5 and 6, that application of computational thinking through coding is right out there. So that's the that side. So what I'd like to do next is, and I hope we can get through this. This is sort of the this is the imposter syndrome part. This is where I am not a Division I teacher. I am a teacher. And so we have instructions, creativity, computational thinking, design thinking, creation of artifacts. How can they move together? So I've mentioned there's no specific coding until grade 5. Now, am I in the right spot? Yes, I am. But we can use those non-tech opportunities. They do develop K-3 computational thinking skills. So if you're not one of the group of us who loves those little robots, don't worry, because these are those questions that you are looking at all the way up to grade 3, and it's not coding. And so when we look at kindergarten, grade 1, grade 2, grade 3, instructions, creativity and design, creativity, computational thinking, and investigating creativity. So none of that is looking at the coding side of things. And really, it's not until you get to grade 5 and they're creating artifacts that can be used by a human or machine to address a need. That's where the coding comes in. And by the time you get to, yes, Seema, thank you for sharing that link. Guiding question in grade 6 is looking at abstraction, design, and coding. And now that we've talked about computational thinking, you actually know what these things mean. And so I see it very much. And Nicole talked yesterday too about the whole notion of gradual release of responsibility, like I do, we do, you do, and sometimes there's this you do it together with the scientific method. But you can see through here, it's very much the same thing with computational thinking as well. And yes, exactly. The comment in the chat about creativity, computational thinking, design thinking always existed. And the new curriculum is identifying the processes and coining them with specific terminology. And I love that. When I first saw it, I thought, that's really neat, because we need to know this, but we already did it all along. But that's that name it to know it piece. Now, and Nicole will be sharing all of these links at the end, but I'll just pop them in the chat as well. So one of the resources that I found I needed to create, and so just kind of on a meta level here, when putting this presentation together, I found, and in these slides where I've got these screenshots from the curriculum, it's messy. Like when you're on the when you're on the the site, like there's sort of big gaps of space between cusps and so forth. And so what I realized is it would be really helpful just to be able to have the cusps in such a format that they can just be printed off and cut up and literally overlaid onto other organizing ideas. So what I did is I went through, as you can see here, I've got my kindergarten cusps, my grade was just for computer science. So grade 1, grade 2, there were lots of them, grade 3, and then I took computational thinking, that model, and put those on a couple as well. And so feel free to take this and to print it up, cut it in half. And then when you're doing your planning, what a great way to integrate them, right? To be able to just say, okay, I'm focusing on this in energy. Is there something in computer science that works? And it's just pass the card out. And I found that helpful. Taylor's asking if there was a template I used. I literally, this is the ed tech side of me, and we really don't have time, but I love this stuff, is I just went to my Google Slides and I created my Google Slides, like one per cusp. And then first thing I did is I changed my page size. So it was, the shape of the cusp card. And then I just copy pasted over. And then I went, I made a PDF, but what I did is I put 2 slides per page. And that's how I got them 2 per page. So it was like in my print preview, I said 2 per page. So that's how you do things like that. Anyway, yes, so hopefully, so now I want to take you through, you're very welcome. I want to take you through this. I hope this isn't confusing for you. If it is, let it go. This is just the way my mind worked as someone who's not familiar with teaching young children. So I looked at, yes, Amber, exactly. Slides are amazing. Anyway, so I looked at the cusps for kindergarten computer science, and I thought, okay, if I am going to put together an activity, what in my own words, I sort of put in my own words, these are the sorts of things I would want to put into that activity. And so then I thought, okay, how am I, what is that, what might that activity look like? And so myself, I guess it's like design thinking. It is, I didn't even think of that. Look here, this is that empathy piece of the design thinking. And then here, I started to ideate what are some possibilities for activities for kindergarten that are computer science. And I need to read that book. And so we're going to flip back over to Lumio again, just because I looked, and it's this whole idea of what if there's an activity that's already created. So what it's asking you to do in the curriculum itself is that the students are asked to follow 1 and 2 step instructions. And so this is just a traditional kind of smart notebook activity where students, and it's a rank order activity. And so what you'll see on your screen, if you've gone back to your Lumio tab, is you'll be able to click, there's a start button. And so on your screen, you'll be able to move these into the order. And if it's in the wrong place, it spits it back. So I guess we're going to be drying our hands at the end. No. So anyway, of course, I can't think about washing my hands and talk at the same time. And sing happy birthday. So this is an example of, it's called a rank order activity in Lumio, where you put things in order. And I see I can click in here, and I can see how well you're progressing. So some of you are, Dawn is done. But that gives an example, just a little activity of where students are following, and it's more than a 2-step instruction, but to be able to use an activity like that, to be able to model for them, creating that kind of an instruction, that's something you can do without using language. But as you know, I'm not a kindergarten teacher, but that was one idea that I ran across that I thought this might work for you. Looks like my screen has frozen here. Hopefully it comes back. I'm going to press refresh, so I don't know what that's going to do to all of you. We'll see. I certainly don't want you all to have to join my class again. Okay, I'm going to keep going on this one, and hopefully that will find its way back. So, oh, that's all the way to the grade 3. I'm going to just see if I can pull this back. How unfortunate to have a network issue at my end. I'm going to stop it. I'm going to close out of it. You're going to see how to get into Lumio. If you have Lumio, you can get in through your Google Drive. I'm just going to go straight through the site. Nicole, feel free to make any comments or ask things as I pull this out.
see my screen too. A little bit.
Oh, look, 98 of you is still here. That's good. Okay, I'll put the link up. So if things have frozen, you might need to refresh your screen as well. And I'll just click in. Grab that link again if you need to join again. So Lumio is like the 21st century version of Smart Notebook. And it's fantastic. Like, to me, when everything moved online in 2020, like, what a wonderful way for teachers to be able to keep their students on the same screen, right? So anyway, that will take you back in here, and I will just find our slide. That was at the washing hands. Okay, so I'm going to go to the next one. Okay, so hopefully you're in on there. I can see we're down a little bit in the numbers. And Rosemary has her hand raised. Rosemary, question, comment?
I would just like to ask a quick question. Our board does not use smart boards, and we do not use the smart board programs. Would this still work on a Promethean board?
Yes. So just a sort of so yes, because all it is an online program. So it would work on any sort of display. Like right now, I'm not using a smart board. I'm just using my computer display, right? But it's not bad. Districts like purchase it to have unlimited storage space. If your district has not purchased it and not blocked it, then there is still a free teacher version, which is still full featured. The only difference is that you don't have very much storage space. So you would have to like get rid of the files that you're no longer using and just have a very small lot of files. But it's nice that it is a full featured free version too. Yes.
Perfect. Thank you.
Mm-hmm. And it works as you see, it works on phones, on iPads, on like whatever device. It's very device agnostic, they say. Anyway, back to computing science. So here's an example. And again, this is me. I'm not a math teacher. I'm not a kindergarten teacher. And here I am giving suggestions. So please know, I do not consider myself an expert in any way. So I was looking at the cusps. And so I thought, okay, so under math, I was able to, because I was looking at the computer science ones first, and I was thinking, okay, we need to follow a sequence of 2 steps related to a learning experience and these other things here. And so I thought, well, I wonder if this would work. And so your Division 1 teachers, I don't really know what supertize means. But I thought, okay, if we're comparing the sizes of different things or looking at, what is more and what is less, I wonder if I can find an activity that does that. And so here's another example of another rank order activity where the students are asked to count the sides of things and put them into the order. So, and again, it's going to give the mark right away if they get it right. And if they get it wrong, they miss the hoop. And so that's another one that you can go in and just play with for a minute as I move along. And so these were just found in, like in Lumio, you saw where I was getting into the file again. They just have a whole like a lot of resources that you can go in and search. And of course, you may need to change and make your own. So if you find, a big frog sitting on your life cycles files, you might want to get rid of it. So I'm going to keep another couple of examples here to be able to look at a quantity and know what it is without. Oh, that's interesting. So would that still work for that file, that math shapes and sides, if you just look at it and say, hey, I really think this is more, because you just know it's got more? Would that be supertizing? I'll let somebody answer that and I'll keep going here because think, okay. And so here's another one, ordering numbers, and don't fiddle in here. I'm just going to go really fast through them. And so the next thing I started to think about, so I looked at those thought processes and then kind of that design thinking. And then it was like, okay, so I'm going to look for these connections for how it fits computer science. And I thought, let's get more concrete. How can I find something that's computer science and another organizing idea? Yeah, thank you, Ruth. Yes, thank you. I now know. So kindergarten matter and computing science. Under kindergarten matter, so we have the idea of examining properties of various objects using one or more of the 5 senses, describe properties of various objects, sort various objects according to properties and compare the properties. And then under computing science, recognize when actions do not correspond to instructions, match an action to the corresponding instruction, engage in activities that involve following instructions in various contexts and so forth. And so what I thought is, well, what if we had some T-charts and had that conversation with students? And these may not be the right words, that probably aren't, but for you to just take that concept of using the T-chart and the objects, and what might that look like when you're working with students. And so here we have those cusps. And so then with students, of course, then you can have that activity where you do it on the board together to sort things into their places, or within Lumia, which I'm not going to show you because this isn't a Lumia presentation, but I can make this like, where everybody or groups can work together to do this on their own devices. So you could have those conversations thinking, what are the instructions you need to follow? And let's come up with those and co-create those instructions and then complete them as a class. So I'm actually curious what you think about that one as well. Those of you who like those little robots, somebody mentioned up in the chat earlier, they mentioned the CS Unplugged website, which is, yes, Nicole, exactly. The CS Unplugged website gives all kinds of activities that students can use to engage in various computer science activities without knowing how to do any coding. And so one thing that struck me is if you give students, and these, I just grabbed the screenshots for these little images from the Scratch website. And so to have that conversation to say, okay, what does this one mean? And if this one means move, oh, it doesn't, it means move right. It will put those into place so you can do those together. So if this means move right, and this means move down, so you think of this as a sort of whole class activity, that can help students get a sense of those directions so that you could put together a 2-step instruction and have them stand up and have them move right, have them move down, right? And so Jenny, yes, Ozobots, Bbots, Spheros, and all of them, yes. And I have a list I'll share with you at the end. So not thinking of the robots yet, although this obviously works for them, to think of knowing those concepts, practicing those concepts, and then being able to reconfigure them in a different order, which will fit one of the other cusps, to be able to have students internalize them through practicing with body coding would be a great way for them to do that. So that's kindergarten. We have 10 minutes, and I'm thinking maybe what I'm going to do is skip forward really quickly so that I don't go on for another hour and a half. So I'll just flip through these. You'll see that just as with kindergarten, how I had some examples, I've done the same with grade 1. So some general examples, some general ideas of what that might look like. You will have all of these resources. I was looking at the idea of instructions affecting outcomes and different ways of sorting shapes in order to have that conversation. And then I use the same template, which I have sharing with you with those resources. And again, looking at living systems and computer science and what might be some potential activities to do that. I originally made the activities, but I kind of backed up. I think they need a little bit more work, but the activity ideas are here. We've talked about the idea of using the body coding or using little robots. And so in this video here, I am actually trying to get the mouse to the cheese. And earlier I talked about how you get onto you're like a dog with a bone when something doesn't work the way it's supposed to. And you will see that in this video.
Let's see whether our planning on how to get Colby the robot mouse to the cheese is correct. We've decided here that he's going to go forward and turn left, go forward 2 times and turn right, go forward 2 times and turn left, and go forward 1 time. So we're going to see if that actually works. So I'm going to go to program him. And so I'm going to go forward and then I'm going to turn left and go forward 2 times.
So I'm going to interrupt myself as it's
right,
doing that.
and then go forward 2
Yes,
times.
thank you. Put in
And then
connections that
again.
you see.
And then go forward 1 time and hopefully he will get to his cheese. So let's press play.
So of course, I think it's going to work because I know it'll work. What I didn't account for was that the cards would turn it down. So I probably should have removed the cards, right? I love connecting with LA.
Ah, so close. That would be a conversation and then we would do it again.
Yes, keep writing in the chat. Where else do you see this coming up, or other robots that you're familiar with that would be able to do the same thing, like the Bebots?
Yes.
So that's Colby the Code and Go mouse. They're a lot cheaper than Bebots. And Rosemary, your hand is up. Did you have a question? Okay, I'm going to keep going and I'm going to go as fast as I can here. This is taking, you saw that activity where we were doing the matching directions in kindergarten. I thought, well, wouldn't it be interesting to take the same concept and look at how instructions affect outcomes in grade 1? And they could do it with the actual robot, but they could also do it this way, where you can take your card and you can decide how am I going to, he's going to go forward, he's going to go here, he's going to turn right. I don't know, whichever. So the idea of pulling the directions this way, and if you do it in another order, will you get the same results? So that would be an activity that helps you do that. And this link up here takes us to where I got those images for the cards. Thank you, Seema, for sharing the code.org website. Code.org is one of my favorites. So match instructions so again, science learning outcomes, follow instructions and relate them to outcomes. What if we want to get the dog? How would we move these into place to get the dog around the lake to get him to his bone? So all of those are examples of that. Grade 2 has more computer science cusps. And so this was the example that Nicole had shared in another presentation where her students had co-created. So now the students were creating the instructions collaboratively with the teacher. So they have the 2-step instructions that they have created using the organizing idea from computer science in order to sort things into what grows and what doesn't grow. And that just grabbed my imagination. And so I thought, well, what if we take what Nicole's done, if students are creating those instructions together, and we could put them into one of those activities in Lumio as well. And so kind of like it's called a super sort activity where you can look at what grows and what doesn't grow. So lots of examples, how to make, this is a video, this takes you there, it's in the presentation, how to make a peanut butter sandwich. You might have seen that before. So there's an example for that. There's an activity about let's make a sandwich, where you would put those things in instruction as you're prepping students to be able to write it themselves. So I want to move as quickly as I can because I know our time is short. This is an example of the same sort of thing. I do not want to put you in teams. So let's go back here. So the idea here would be to test your instructions on the grid and then actually create it within Scratch itself, which grade 4 kids can totally do. And so other sample activities are in here. So this is grade 2, and then the grade 3 ones I actually have back in my presentation. Sorry, I'm looking at the clock and I hope I'm not going too quickly. So you'll see in the presentation that under grade 3, we're looking at how creativity contributes to computational thinking. And grade 3, as mentioned before, gets very specifically into those components of computational thinking and builds upon what comes before. And so the activities that I put together as samples, one is the idea of creating and test instructions for making a healthy snack. And the other one is actually an activity that, oh, that's excellent, seeing it vividly, where computational thinking is like I think it's the through line that takes you into it. So this is an example from the Raspberry Pi Foundation. So we're looking at the grade 3. And the idea is that students will make a flower generator. And so that's for those students. And there's a video that shows you how to do it. And there is the activity itself that's available online. The one piece of, when you think of that digital promise, like Venn diagram that I showed you at the beginning, where we had like computer science and computational thinking and programming down in the corner there. One thing in computer science is that it includes like history of computer science and other pieces. And I found it interesting that there's this cusp in grade 3 that most of it is like create a set of instructions, but then there's this part about examine a Canadian invention and identify examples of creativity in computer science, technology, or engineering. And so I think it would be cool. And I've worked on this and I've removed the link because I'm not quite happy yet. But the idea of exploring creativity in Canadian inventions. And so I hope I can add this to your resource package later. I put together a list of 3 or 4 websites. I have no idea how many Canadian inventions there are. Maybe you know this from other work you've done with kids. But the idea would be that students would work with a group or partners, choose an invention, and to be able to put together their project where they're sharing their invention with the class. But the sort of piece of it, the kicker of it, is how can they, through their process of putting their project together, be demonstrating those skills up here, like create a set of instructions that could be followed. Like how can they use creativity? Computational thinking is a problem-solving process that uses creativity. How can they work through their research process using creativity to solve those problems? So it's like the process of putting their project together is going to become absolutely as much covering off outcomes as the project itself. So I kind of leave that with you as kind of an extension thing to keep you up at night. Grade 4, 5, and 6, this just gives us where these things move forward. And we've talked about that a little bit earlier. And I'm afraid I'm going to go a couple of minutes over time, but I'll try to go fast. Our second takeaway is that whole idea of we have to do it to be it. And just like in that example where I was using Colby the robot mouse to, that suddenly took me in that, why did I get it wrong? How can I fix this? We too, as teachers, we need to like get involved, get our hands dirty with this stuff, because it's like on that meta level, that's what will connect us. And the same with our students. If they engage in these kinds of activities, name it to know it, and then do it, then we will be it. So that's kind of my kind of takeaway of that. But we have more. So how can we teach it and support each other, integrating it into instructional practices when we've never taken a computer science course ourselves? And so some suggested ways, I've shared the CUS cards with you already. Use those to help overlay it on the curriculum. Use the vocabulary. Isn't that interesting, Leslie? Yeah, it's so interesting. I thought I need to be in that class and learn with the kids. Use the words from design thinking, use our outcomes. If you are a more visual learner yourself, I do have some mind maps. I feel that they are still kind of in draft format, but you're welcome to take them and use them. You might find there are little bits that are missing. That's the template, as you've seen, that I've been using when developing some of my own lesson ideas. Use at your own risk. There are probably better ones out there. Develop your PLN, keep curious. And remember, in the end, I believe that this is about literacy, because once they have those skills in place, not only is this preparing them for science, but it's processes that integrate across all, thank you, Nicole, all subject areas. There are websites that will be in the presentation that you have access to. CS Unplugged is one we've talked about today. Code.org is another one that's come up in the chat. All of these websites are fantastic. People who work in this area are passionate about it, and there's so many resources. These are some of the robots that I've referred to through the course of our presentation today, and we have playgrounds in the fall at ERLC, as I mentioned before, on Thursday afternoons. And so I'm hoping, and I'm not going to ask you to do this, we can just do it in the chat for his time's sake, but how are we, not just computational thinking, but in our classrooms, do you see things that you are doing already now that integrates computer science? And what are your takeaways and next steps? I'd really like to hear from you. So just go to the chat, and as I just kind of babble here, and then I'll go back and see what you come up with. So that question, it's how are we integrating computer science already? What are your takeaways and next steps? And honestly, what else can I do to help you? I would like to know that too. We do have sessions coming in the fall. I'm giving them. Angela Deering is giving a session similar to this at the end of August, which will be fantastic. Trevor Yampen is working with ERLC to deliver a computational thinking course that will give you university credit at by the end of next summer, and which is the next chapter of our ongoing Tech in Schools collaboration with the U of A, which also gives university credit. Braden Cagle is giving sessions looking specifically Div 2, Div 3, that overlap, lots going on. So I was going to say seize the day, but I thought it's kind of like seize the moment. My email address, if you have any other comments or questions or requests, I want to be here. As you know, people here are passionate. We have over 100 people in here, and yet we have how many teachers teaching Division 1 across the entire province? 128 people is only a few schools, right? And so all of you as leaders in your own work, the more you spread the word, the more you get these resources out to people. We want you to share them. We want you to use them. And I just wanted to wish you all your best in your next steps. Thank you so much for coming and for taking the risk with me to step out into the arena there with that crazy Lumio stuff. Yeah, thanks. Come again. I'm going to stop sharing my screen.
Thank you, Janet. I think earlier in the chat, people were getting very inspired and starting to make so many connections with different subject areas of how they could see that interconnection. And people are talking about being more intentional with their language and some of their takeaways, and how they already do this, but it's kind of bringing the language out and some really great, they're really appreciative of the resources and the things that you were providing. So wonderful. So, and it was great for me to be part of this. I loved to see this, and I learned a lot as well. So thank you so much. And thank you to everyone for taking risks and going in that Lumio. That was wonderful.
Well, and I mean, I feel we're so blessed to have Nicole with us today. And like, I am really looking forward to future collaborations with Nicole as we kind of work on weaving these things more together. You know, we aren't experts, and we are really across the province. We're building this bridge as we walk on it, but that's a time for opportunity, right? And it's like, here we can work together and we can do it right.
Yeah, it was awesome. And tomorrow, I think Jessica and Chris are going to tie it all together in a nice bow.
Yes. And thank you. As I just see the comments coming in, we're going to make sure that, you know, you'll be getting the Zoom link or the recording, of course, afterwards. And then also we'll make sure that we send out the chat transcript as well, because there's so much, it's the wisdom in the room, right? Is what I think is so great about this kind of opportunity for us all.
Yeah, absolutely.
The little mouse was called Colby, the Code and Go mouse. And oh, I forgot to show you. I'm going to show you one more thing. Where is it? Nicole shared. Nicole, do you want to paste that link in the chat to that resource page again? Because I can.
Yeah, I will.
And I'll just kind of open it. So in the page of resources, that one that Nicole, so if you click on that note in the chat, because I know I'm not sharing my screen anymore, you'll see at the top is like the presentation and then the link down to that Lumio piece and the cusp cards. But if you go, I forgot where I'm going. So if you scroll down, I created this in Wakelet, and down near the bottom, you'll see there's a number of Wakelet collections. So there's design thinking, PBL, inquiry and projects, there's computational thinking, computer science general, and then there's coding in divisions 1 and 2. And so that coding in divisions 1 and 2 link takes you to like to Scratch and code.org and all of those kinds of websites. And then at the very bottom of that page, I just put in some links about the Botley, the coding robot. Oh, thank you, Nicole. That was smart. Yes. So down those last little pieces those are some of the robots that we referred to, but you'll also see in that Wakelet link to the coding, there's a whole bunch of stuff in there too.
Great resources.
Yeah. I would love to I guess we can stop the recording now. I'll just.
Oh, okay. You got it right. Yeah, I forgot.
It's all good. So I'm just going to say we do with the Tech in Schools University collaboration that we have in ARLC, people take 24 hours of sessions from myself or from Darren Maltese or Trevor Yampin, and we'll probably let Braden's be part of that too. So in there, like anybody can take them. You don't have to be part of the cohort. You can come into whatever sessions, but there's one on maker spaces and what is it? Maker spaces. Anyway, there's maker spaces in there. There's computational thinking in there. Design computational thinking. I think we did maker spaces and design thinking together, and then we did computational thinking separately. So if you're interested in any of that sort of robotics things, in those sessions, I'll share lists of, what I would buy if someone gave me $10,000 and said, spend it on robots, what I would do, things like that I can share. And if you're interested, you can email me and I can send them to you.
Oh, someone's asking about a lesson.
Is there a link for the university robotic information? They will be posted up on the ARLC website, but I don't think they have it up yet. So what I would do is probably send me an email, and then as soon as it's up, I'll email it to you. Otherwise, you would just go up to the website and just search
I'm-
computational thinking, but probably easier just to email me and I'll email you.
And I'm assuming that's probably a fall course.
Yes,
so
so with
maybe
that one, it's
mid-August.
similar to the other where he's
Yeah.
going to have 12 sessions over the, I actually love this philosophy of it. It's 12 sessions over the course of the year, 2 hours each.
Yeah.
And then in the summer, there's a 3-week course, but your 12 sessions will have completed the first 4 days. So you don't have to join that course until the Friday, which is when the people who've taken it Monday to Thursday and you all become one big group for 1 day. And then for the next 2 weeks, it's creating your Scratch project. So it's so just from a pedagogy standpoint, right? If I learn things 4 days in a row in a university summer course versus that same material over 10 months of schooling with all of that time to consolidate things and practice, obviously you're going to have a better learning experience over, you know, taking it over that longer time.
And is it a graduate level credit?
It's graduate, you get graduate credit. And it's one of the courses in, there's a graduate certificate that, and then there's a, like a digital citizenship, not citizenship, well, that sort of thing course. And let me make sure I get that. So, and then the technology in schools one that Darren and I do through the year, that gives you credit for one of the course. So with that one, you take 24 hours of sessions with me and Darren, and then me and or Darren. And then all you do in the summer is write a paper, and then they mark the paper, it's pass fail. And then with us, you also have to write a reflection. There's a little bit of extra stuff, but it's not that much. It's mostly just, the idea is that it's a way to give teachers university credit for the professional learning they're already doing.
And this is through ERLC, just somebody.
And that is through ERLC. Yep.
Yeah. And then they'll talk about how to get the credit. Once you're in the course, they'll kind of go through it.
Yes, we'll have an information session, and we haven't set up our dates yet, but probably our first info session will be sometime around the end of September. And then we'll bring in Mike from the university, and the group of us will explain what it's about. So if you're interested in that too, just I'll put my email in there. Send me an email, because then I can let you know once we have that date up. So lots going on. New curriculum.
Yeah. Second year for a lot of you, hey, for ELL and math, and then now science. So a little bit of changes, hey.
Yeah. So I've just getting a little bit, you'll see me being quiet here. I'm just getting a little bit, I've had a couple of direct messages in the chat and I haven't read them. I'm going to read them. Thank you everybody for your nice comments. Yes, so that's these courses are through ERLC, but it's in collaboration with the U of A. And so the guy who's teaching the 24 hours of computational thinking through the year with ERLC is the same person who teaches it at the university. So that's how he's able to pull everybody in day 5, because like it's the same course and the same instructor. Great. Thank you, Ismina. I forgot what I was going to say. Yeah. Yes. So some people are dropping email ad. I'd say just to keep me organized and on track, if you just email me, I should have made a Google form saying, let me know if you want to stay in for the, there for the courses, but I didn't think of that. But yeah, just send me a quick email and I will put all of your email addresses in one spot, and then I will be sure to send you that information. We would love to have you in there. And so in the one with me and Darren, so you do those hours, and then paper in the summer. The paper is on a topic that has to do with educational technology that is close to you. And so when I think of you like shifting from the old curriculum to the new curriculum, I mean, that's something that's going to be very much like in your heart and your mind as you move through this year. And so what incredible experiences to capture and reflect on, and then build back into the research in a paper in the summertime would be really interesting. The possibilities there.
Sure. Yeah. We'll have lots of that. Oh, someone's saying if you put in a Google Doc, that's a great idea.
Well, there we go. Right. Hang on. I'm just going to go to my other screen here now that I've lost my cursor. Okay. Doc.new.
Yes, Ruth, it is a total paradigm shift, especially for science. It's a new shift. Yeah. Yeah.
I'll just call this Contacts for Tech in Schools courses. Save. And I'm going to share it so that, whoops. Anyone with the link? And edit. Copy link.
Yeah,
And
separating now, it's sort of, looking at how the subject can support as well. Yeah, looking at that shift too.
so there's the link to our doc. I'm just going to put a table in there to kind of keep us organized.
Yes, Danielle, she said that the courses will go towards a grad, so like you'll get credit for a grad course for it. Thank you, Selena. Have a great day.
I'm not sure how we ended up with so many columns in there. I'm just going to get rid of those two middle ones. Look at all these: anonymous kangaroo, anonymous cheetah, anonymous duck. Yeah, thank you so much for your time, everybody. I really appreciated the rich conversation, and there's lots for me to get caught up on. This is a revolution from science in a box. Yeah.
Well, I'm probably going to head out, Janet. You have a wonderful day. It was a great session. I enjoyed this. This was nice to co-host that. I didn't feel like I did much though. You were always dropping things in the chat. I'm like, yesterday I was so blind, but you have two monitors, right? Because I only have one. And I was like, oh God, she was like on that chat. But I'd be like trying to answer, and then all of a sudden you'd be like, yes, so and so. And I was like, wow, she's like on the ball.
I think I'm probably ADD, and so I'm like distracted by everything.
You have
everything everywhere all at
monitors,
once, right?
Yeah.
I do have. I've got my little monitor here, and then my big one up here. But yeah, feel free to add more rows to that table. Oh, that's fantastic to see your interest. So I hope you turn up, and hopefully end of September we can get an info session.
People are interested in that, so that'd be great.
Mm-hmm.
Trevor's got some really great ideas too, so lots of really great information as well. So, all right.
And thank you for everybody's patience with the fact that I shouldn't say I know nothing about kids that age, because I have children and I have grandchildren, and my grandchildren are in that age group. And so, of course, code.org is what you do at grandma's house.
Yeah. No, I think it was really good. I think you had some really great suggestions, and people were really thinking like, cross-curricularly, which is nice.
Yeah. So, actually, that would be a fun session to do, is to really like focus on some cross-curricular. But I'd love to work with you, Nicole. You have no idea how much you make me feel grounded.
Well, I like working with you too. It was fun working on the ATLE stuff together, and seeing that connection and stuff. So Anyways, well, I'm
Anyway,
gonna run.
I think we all have to go. So look, thank you so much. Of course,
Yeah.
you can keep writing in that doc if you like, and look forward to sending the links out soon.
Have a great day. See you, Janet. Enjoy the rest of your day.
Yes, you too, and same all of you. Bye-bye.
Bye-bye.